Picture this, a universe so vast, so mind-bendingly immense, that the very thought of it makes your heart race and your mind reel. A cosmos where the smallest speck of existence is as alien to us as the farthest galaxy, where scales of size and time defy everything we think we know. This isn't just a story of stars and planets. It's a journey into the incomprehensible, a plunge into the shocking truths that govern reality itself. Hold on tight, because we're about to unravel the scales that rule the universe, and trust me, nothing will prepare you for what's coming. Let's start close to home with the way we measure the world. Think about it: a foot, an inch, a meter. These units feel so natural, don't they? They're as familiar as the rhythm of your breath. But peel back the curtain, and you'll see they're rooted in something utterly mundane: our own bodies. The length of a foot, the span of a hand, the stride of a step. Historically, that's how we made sense of size, tethering the world to our biology. It's human, it's relatable. But here's the kicker: it's not fundamental. These measurements tell us nothing profound about the deep structure of the cosmos. They're just a fleeting human lens, a tiny blip in the grand scheme of existence. Now imagine meeting an alien civilization, not little green men, but beings so different they might not even have limbs or eyes. What would we share with them? How would we communicate scale? A meter means nothing to a creature without a body like ours. A foot is useless to something that floats in a gas giant's atmosphere. So what's the universal language? What's the cosmic yardstick that transcends biology? The answer lies in the fundamental quantities that stitch the universe together, the unshakable constants that define reality itself. First, there's the speed of light. It's not just fast, it's the ultimate speed limit. Anything without mass, like a photon, zips along at this cosmic velocity, a staggering 299,792,458 meters per second. If you have even a whisper of mass, you're barred from reaching it. No matter how hard you push, the universe says, "Not today." This speed isn't just a number, it's a law, a boundary etched into the fabric of existence. It's the same everywhere for everyone, whether you're a human or a blob of plasma on a distant star. Then there's gravity, the force that sculpts the cosmos. Picture two massive objects, say a pair of stars. The strength of their gravitational pull depends on a number called the gravitational constant, first measured in the late 18th century. This constant tells us how much one mass tugs on another, or in the language of Einstein, how matter and energy warp the very space-time around them. It's the invisible hand that keeps planets in orbit, galaxies spinning, and the universe from flying apart. Finally, there's a strange, almost mystical number called Planck's constant. Discovered in 1900, it's the key to the quantum world, the realm of the impossibly small. It tells us that energy comes in tiny, discrete packets, like grains of sand, instead of a smooth flow. It sets a limit on how precisely we can know a particle's position and momentum, a fundamental fuzziness baked into reality. Want to know the energy of a photon? Multiply Planck's constant by its frequency. It's a number so small it's hard to grasp, but it's the cornerstone of the subatomic world. These three, speed of light, gravitational constant, Planck's constant, aren't just numbers. They're the building blocks of the universe's architecture. Combine them, and you get something extraordinary: the Planck length. It's a distance so tiny it defies comprehension, about 1.6 times 10 to the minus 35 meters. That's a decimal point, followed by 34 zeros and then a 1. To put it in perspective, if you blew up a proton to the size of our solar system, stretching from the Sun to Neptune, the Planck length would still be as small as a virus or a single cell. It's not just small, it's the smallest scale we can meaningfully talk about. Why does this matter? Because the Planck length might be the universe's ultimate pixel, the smallest unit of space itself. Try to probe something smaller, and the rules of physics break down. Shine light with a tiny enough wavelength to see the Planck length, and you need so much energy that you create a black hole. Pump in more energy, and the black hole grows, hiding the very thing you're trying to observe. It's as if the universe is saying, this far and no further. The Planck length isn't just a measurement, it's a boundary, a hint that reality itself has a grainy, fundamental structure. Now let's zoom out, because the universe doesn't just play at the small scale, it goes big too. Start with something familiar, the distance to the moon. It's about 384,000 kilometers away, close enough that light takes just over a second to get there. The moon looks big in the sky, about the same size as the sun, a cosmic coincidence that gives us those jaw-dropping solar eclipses. But step up to the sun, and things get wilder. It's 93 million miles away, an astronomical unit that takes light 8 minutes to cross. The sun is so massive you could fit 1 million Earths inside it. Its radius is 100 times Earth's. Imagine flying around it in a passenger jet. It'd take you a year to complete the trip. And the sun? It's just a small star, a cosmic nobody in the grand scheme. Push further. The Voyager 1 spacecraft, launched in the 1970s, is the farthest human-made object from Earth. It's over 150 astronomical units away. So far that a signal traveling at the speed of light takes 22 hours to reach it. That's a machine we built, still whispering back to us across a void most of us can't even fathom. Now think bigger. A light year, the distance light travels in a year, about 5.9 trillion miles. The edge of the sun's influence, the Oort cloud, is 365 light-years away. The nearest star, Proxima Centauri, is over 4 light-years from us. These distances aren't just numbers, they're a slap in the face to our intuition. Keep going, and you hit the Milky Way, our galactic home. It's a swirling city of 200 to 400 billion stars, stretching 100,000 light-years across. That's so vast that light from one side takes 100,000 years to reach the other. And yet, it's just one galaxy. Look up on a clear night, away from city lights, and you might glimpse the Andromeda Galaxy, our nearest large neighbor. It's 2.5 million light-years away, meaning the light hitting your eyes began its journey before humans even existed. That's not just distance. It's time travel, a window into a universe that was younger when that light set out. Now brace yourself, because the scales are about to get truly unhinged. With telescopes like the James Webb Space Telescope, we've seen galaxies so distant their light has traveled for over 13 billion years to reach us. That's 13,000 million years, almost the entire age of the universe. But here's the gut punch. The universe has been expanding this whole time. The light we see from the cosmic microwave background, the afterglow of the Big Bang, was emitted just 380,000 years after the universe began. It's been traveling for 13.8 billion years, but the place it came from, it's now about 46 billion light-years away, thanks to cosmic expansion. The observable universe, the part we can theoretically see, spans 92 billion light-years. And beyond that, the universe might be infinite. Infinite. Let that sink in. No edge, no end, just more and more forever. This is where your mind starts to buckle. The universe isn't just big, it's so vast that big loses all meaning. We're not even a speck in this cosmic ocean, we're a fleeting whisper, a momentary flicker in an eternity of space and time. It's humbling, isn't it? You might feel small, insignificant, like nothing we do matters against this backdrop of incomprehensible scale. But hold on, because there's another side to this story, one that's as uplifting as it is mind-blowing. What if life, yes, life like us, could change the universe? It sounds crazy, but hear this out. Imagine life persisting, evolving, growing smarter and more powerful over billions of years, not just colonizing planets, but reshaping solar systems, galaxies, maybe even the fabric of the cosmos itself. What if life could manipulate the universe to become immortal, to outlast the stars? This isn't science fiction, it's a possibility rooted in the very nature of knowledge and progress. The universe might be vast, but life has something unique. The ability to understand, to create, to defy the odds. Suddenly, we're not just a speck. We're a spark, a seed of potential that could one day light up the cosmos. Let's pull back to the small scale again, because the universe isn't just about the big, it's about the extremes. Down at the Planck length, we're brushing against the limits of physics, but there's another frontier, the quantum world. Particles don't behave like tiny marbles. They're waves, probabilities, smeared across space. Heisenberg's uncertainty principle, tied to Planck's constant, tells us we can't pin down a particle's position and momentum at the same time. The more we know about one, the less we know about the other. It's not a flaw in our tools. It's a fundamental truth. Reality at its smallest scales is fuzzy, indeterminate, almost dreamlike. This quantum weirdness doesn't just stay small. It shapes everything. The energy levels in atoms, the glow of stars, the fusion that powers the sun, all of it traces back to quantum mechanics. Even the Big Bang, the moment the universe burst into being, was a quantum event, a fluctuation in a primordial void. The Planck length and Planck's constant aren't just abstract. They're the seeds from which the entire cosmos grew. The smallest scales and the largest are intertwined, two sides of the same cosmic coin. Now let's talk about time, because the universe, Isnversity of Maratua, isn't just about space. It's about duration too. The universe is 13.8 billion years old, but what does that mean? It's not just a number. It's a story of change, of evolution. In the first fraction of a second after the Big Bang, the universe expanded faster than light, inflating from a point smaller than a proton to something the size of a grapefruit. That's not just fast, it's a cosmic explosion that set the stage for everything. Over the next 380,000 years, the universe cooled, atoms formed, and light began to travel freely, creating the cosmic microwave background we see today. Fast forward 9 billion years, and stars began forming, forging elements like carbon, oxygen, and iron in their fiery hearts. About 4.6 billion years ago, our Sun and Earth took shape. Life appeared maybe 3.8 billion years ago, a fragile spark in a cosmic ocean. Humans, we've been around for a mere 300,000 years, a blink in the universe's timeline. Yet in that blink, we've built telescopes, launched spacecraft, and peered back to the edge of time itself. That's not just progress. It's a miracle, a testament to the power of curiosity and ingenuity. But time isn't just about the past. It's about the future. Stars will burn out. Galaxies will drift apart. And in trillions of years, the universe might grow cold and dark. Or maybe life will find a way, reshaping the cosmos to sustain itself forever. The scales of time are as staggering as the scales of space, and they force us to confront our place in the grand narrative. Are we a fleeting moment, or the beginning of something eternal? Let's zoom out again, because the universe isn't just about size and time. It's about structure. Galaxies aren't scattered randomly. They form a cosmic web with vast filaments, walls, and voids. The largest structures, like the Great Wall, 1 billion light-years long, are so immense they challenge our understanding of how the universe formed. And yet, they're held together by dark matter, a mysterious substance we can't see but know is there because of its gravitational pull. Dark energy, even a stranger, is pushing the universe apart, accelerating its expansion. Together they make up 95% of the cosmos, leaving ordinary matter, stars, planets, us, as a mere 5%. We're not just small, we're outliers in our own universe. This brings us to a humbling truth. The universe doesn't revolve around us. We're not the center, not the purpose, not even a major player. But that's not a reason to despair. It's a call to awe. The same laws that govern the Planck length govern the galaxies. The same physics that sparked the Big Bang runs through our veins. We're made of star stuff, as one great thinker put it, forged in the hearts of ancient suns. That's not insignificance. That's connection, a profound unity with the cosmos. Now imagine standing under a starry sky, the Milky Way blazing above. Each pinprick of light is a sun, some with planets, maybe even life. The sheer scale of it all could crush you, make you feel like nothing matters. But flip that thought. The fact that we can contemplate these scales, that we can measure the Planck length, map the cosmic web, and dream of immortal life. It's extraordinary. We're not just in the universe, we're of it, a part that can think, feel, and wonder. Let's dive back to the small scale, because the extremes are where the magic happens. At the Planck length, space itself might be quantized, like pixels on a cosmic screen. Some theories, like loop quantum gravity, suggest space-time is woven from tiny loops, smaller than we can ever probe. Others, like string theory, propose that particles aren't points but vibrating strings, with the Planck length as their scale. These ideas aren't just wild. They're attempts to unify quantum mechanics and gravity, to crack the code of the universe's deepest structure. Zoom out, and the large scale is just as wild. The universe's expansion isn't slowing, it's speeding up, driven by dark energy. In billions of years, distant galaxies will slip beyond our view, their light stretched to infinity. The observable universe will shrink, leaving future astronomers with a lonelier sky. But what lies beyond? More galaxies, maybe infinite, or perhaps other universes, a multiverse where every possibility plays out. These ideas aren't just speculation. They're grounded in math, in the same physics that predicts black holes and GPS. This dance of scales, from the Planck length to the cosmic horizon, isn't just about numbers. It's about meaning. It's about confronting the limits of our minds and pushing past them. The universe is vast, but so is our capacity to explore it. Every discovery, from the quantum fuzziness to the cosmic web, is a step toward understanding. And with understanding comes power, not just to control, but to create, to dream, to shape the future. Picture this again. A universe so vast, it humbles us. So intricate, it dazzles us. From the Planck length, where reality blurs, to the cosmic microwave background, a snapshot of creation itself. The scales that rule the universe are beyond comprehension. Yet we comprehend them, bit by bit, through science, through wonder, through sheer stubborn curiosity. We're not just a speck in the cosmos. We're a spark, a mind that can grasp the ungraspable. So what does this mean for you, standing here, reading these words? It means you're part of something bigger, something breathtaking. Every atom in your body was forged in a star. Every thought in your mind echoes the universe's complexity. The scales that rule the cosmos, small, vast, eternal, are your story too. And that's not just shocking, it's beautiful. It's a call to look up, to wonder, to live with the awe of knowing you're a fleeting, miraculous part of the incomprehensible whole.